Hello students, in today's class we are going to continue exercise 6.5. So in yesterday's class we have learnt three theorems, Pythagoras theorem and its converse, and also one more base theorem for Pythagoras. Hope you remember, which says that if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. And using this we have proved Pythagoras theorem, and Pythagoras is a well-known theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides, and we have seen the converse of Pythagoras theorem, right? And in today's class, let us continue solving exercise 6.5. In yesterday's class, we have solved a few problems in exercise 6.5. Let us continue with that. Now, let us move on to 11th question. It is given that an aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. How far apart will be the two planes after 1.5 hours? This was the question. So, let us see how can we solve this. So, there is an aeroplane which moves from the airport and flies due north. This is our north direction at a speed of 1000 km per hour. And at the same time, another aeroplane moves due west. This is our west direction at a speed of 1200 km per hour. They asked you to find out the distance between the two aeroplanes after 1.5 hours, right? And if you draw the diagram and see clearly, it is a right triangle. So if we know this distance and this distance, we can find it using Pythagoras theorem. So we need this distance and this distance. How can we find out what is distance? Distance is speed into time, right? So let us find out the distance traveled by the first aeroplane after 1.5 hours, right? So distance traveled by first plane after 1.5 hours is equals to, what is distance? Speed into time. Speed is 1000 km per hour. So 1000 into 1.5. 1.5 is 2 ones are 2 plus 1 3. So 3 by 2. So which is equals to how much? You can cancel it. 2 5s are 10. So 500 into 3. So 1500 km is the distance travelled by this aeroplane towards north after 1.5 hours, right? And let us find the distance travelled by the second plane. Distance travelled by second plane after 1.5 hours. How much it will be? Again, speed into time. The speed of this plane is 1200 km per hour into 3 by 2. So 2 6 are, so 600, 6 3s are 18, 1800 km. So the distance travelled by this plane is 1800 km, and the distance travelled by this is 1500 km. Now we got the distance between these two. Therefore, if you want, you can name this triangle as ABC, right? Now in triangle ABC, by applying Pythagoras theorem, we can find the distance between those two planes. Therefore, in triangle ABC, by Pythagoras theorem, what we know? AC square is equals to AB square plus BC square. Hope you can solve this by your own. After that, it's mere calculation by using Pythagoras theorem. So 1500 the whole square plus 1800 square. 1500 square is 225. 15 square is 225. And 18 square is 324, added with that many zeros, and if you add that, we got 5490000, right? How will you take the square root of this? This 4 zeros can be written as 100 into 100. 549, if you factorize, it can be written as 9 into 61. 9 is a perfect square, so 9 into 100 into root 61, therefore 300. 9, the square root of 9 is 3, right? So 3 into 100, 300 root 61 kilometer. Therefore, the distance between these planes will be 300 root 61 kilometer after 1.5 hours, right? This is mere application of the Pythagoras theorem. They didn't give you the distance directly, so we found the distance using speed distance time formula, and then we have applied the Pythagoras theorem. Yes, hope you understood. Let us move on to the next question. 12th one. Two poles of heights 6 meter and 11 meters stand on a plain ground. If the distance between the feet of the poles is 12 meter, find the distance between their tops. Yes, let us see how can we solve this now. Now see, it is given in the question there are two poles. One is 11 meter, AB be the one pole of 11 meter long, and another pole is CD of 6 meter long. And they have given the distance between their feet is 12 meter. They asked you to find the distance between their tops, right? We need to find what is this AC. So what are we going to do is, we are going to draw EC parallel to BD such that BE equal to 6 meter. Okay, we are going to draw a parallel line from C to AB, intersect at E. Therefore, BE will become 6 meter. Therefore, what will be AE? Total distance is 11 meter. So, AE will become 5 meter. Right? And what is EC? EC is 12 meter. Now, this becomes right triangle. Right? Therefore, you can very well apply Pythagoras theorem and find what is the length of AC. Yes, hope you understood. I am leaving this problem to you as homework. You are going to do it. Let us move on to the next question. What is our next question? D and E are points on the sides CA and CB respectively of a triangle ABC, right angled at C. Prove that AE square plus BD square is equals to AB square plus DE square. Now let's see how can we do this. Now what is given in the 13th question? ABC is a right angle triangle, right angled at angle C. And they asked you to prove, and also it is given that D and E are points on the sides AC and BC respectively. They asked you to prove AE square plus BD square is equals to AB square plus DE square, right? And if we see there is no relation, direct relation between AE, BD, AB, DE and also we cannot apply any direct relation there. So what shall we do now is, we will find what is AE square, what is BD square, and then we will add those two. Similarly, we will find what is AB square, DE square, and then we will add, right? So where is AE? AE is here. Therefore, consider triangle ACE. Angle C is 90 degree, right? Angle C is 90 degree. Consider triangle ACE. In that angle C is 90 degree. Angle C is 90 degree. Therefore, by Pythagoras theorem, what we know? This is our hypotenuse, right? AE square will be equal to AC square plus CE square. Right? We found what is our AE square. Similarly, where is our BD? BD is here. BD is here. Therefore, let us consider this triangle because here only we have 90 degree. Similarly, in triangle BCD, BD square will be equal to CD square plus BC square. Mark this as 1 and 2. Now let us add 1 and 2. So 1 plus 2, what we will get? AE square plus BD square is equals to AC square plus CE square plus CD square plus BC square. Let it be aside. Now we need AB square and DE square, right? So what is AB square? AB square is this bigger triangle. So in triangle ABC, what is AB square? AB square is equals to AC square plus BC square, right? Similarly, we need DE. Where is DE? DE is here. So in triangle DCE, DE square is equals to CD square plus CE square. Mark this as 4 and 5. Now let us add 4 and 5. So 4 plus 5 will imply AB square plus DE square is equals to AC square plus BC square plus CD square plus CE square. Mark this as 6. So if you compare 3 and 6, what you infer? We got everything same. AC square, BC square, CD square and CE square. Therefore, from 3 and 6, what we infer? AE square plus BD square will be same as AB square plus DE square. Hence we proved. Yes, hope you understood. This is like mere application of our Pythagoras theorem, direct application. But when you see what we need to prove, which cannot be found out directly. So find what is AE square, BD square. Similarly, find what is AB square and DE square. Find out left hand side and right hand side separately and check whether both the answers are same. That's what we did here. Yes, hope you understood. Let us move on to our next question now. Now 14th question, the perpendicular from A on side BC of a triangle ABC intersects BC at D such that DB is equal to 3 times CD. Understand it properly. BD is 3 times CD, right? Which means CD is 1/4 of BC and BD is 3/4 of BC. That's what it means, right? It is given DB. This distance is 3 times CD. 3 times if you add CD, it will be equal to BD, right? So BC total length is divided into 4 parts. Out of 4 parts, 1/4 is CD and 3/4 is BD. That's what it means, right? Then we need to prove that 2AB square equals to 2AC square plus BC square. This again can be easily arrived by applying Pythagoras theorem. See, here it is given. What are all the things given in the question? AD is perpendicular to BC and DB equal to 3 times CD, right? So from the given thing we can write DB is equals to 3 times CD. So this implies CD is equals to 1/4 of BC and BD is equal to 3/4 of BC. Hope you understood how we got this, because it is given DB is 3 times CD. So it is 3 times CD. This is one CD, this is one CD and this is one CD, in the sense that measurement. So on the whole 4 times we have divided BC. Out of that 1/4 is CD and 3/4 is BD. Alright. Now we will apply Pythagoras theorem. We have 2 right triangles here. One is this triangle and the other one is this triangle, right? So in triangle ABD, what we know? AB square is equals to AD square plus BD square by Pythagoras theorem. Similarly, in triangle ACD, this triangle, what we know? AC square is equals to AD square plus CD square. Mark this as 1 and 2. Now we need the relation between AB and AC only, right? And we need in terms of BC also. That's why we found CD and BD in terms of BC. Now let us subtract these two. We should not add. Why we should not add? because one side of the equation we have AB and the other side we have AC. If we add, we won't get our required solution. So we need to subtract. So subtract 1 and 2, right? Subtract, or else you can write subtract 2 from 1. What we will get? Subtract 2 from 1. So AB square minus AC square is equals to AB square minus AC square equals to AD square plus BD square minus of AD square plus CD square, right? So plus AD square minus AD square will get cancelled. We got BD square minus CD square. But what is your BD? BD is 3 by 4 times BC, 3 by 4 times BC the whole square, minus CD is 1 by 4 times BC the whole square. So which is equals to 9 by 16 BC square minus 1 by 16 BC square. So if you take LCM, it will become 9 minus 1 is 8, right? 8 by 16 BC square. So 8 2s are 16. So we got BC square divided by 2. This side we have AB square minus AC square. If we bring 2 to the other side, we will get 2 times AB square minus AC square equals to BC square, or 2 times AB square minus 2 times AC square equals to BC square, or 2 times AB square equals to BC square plus 2 times AC square. This is what we need to prove. Yes, 2 times AB square is equals to 2 times AC square plus BC square. Thus we proved. The only thing you have to understand is what is given. From that you derive the relation between the CD and PD in terms of BC. Apply 2 times Pythagoras theorem and substitute, you will get the answer. Yes, hope you understood. Now let us see how can we solve our 15th question. It is given ABC is an equilateral triangle such that BD is equals to 1 by 3 times BC. We need to prove that 9 times AD square is equals to 7 times AB square, right? So first, before we get into the proof, we recall the properties of equilateral triangle. What are all the things we know about equilateral triangle? All the 3 sides will be equal, each angle is 60 degree, and in the last exercise even we have solved a problem which says the length of the altitude will be root 3 into half of the side. Hope you remember. We have assumed the side of the equilateral triangle as 2a and we have proved the length of the altitude as root 3a. Let me show you so that you can recall that problem. See here. 6th question. ABC is an equilateral triangle of side 2a. They asked you to find the length of the altitude. We have assumed it as 2a and we have proved AD is root 3a. Therefore, if the side is 2a, length of the altitude is root 3a, which is half of the side, right? So here we have assumed the side of the equilateral triangle as a. Therefore, length of altitude will be root 3 into a by 2. So AE, we have drawn an altitude AE. Length of AE is going to be a root 3 by 2. And also we have used this result in proving that problem even. In an equilateral triangle, the altitude will divide the base into 2 equal parts. It will bisect the base. I told you this is possible only in isosceles triangle and hence in equilateral triangle by congruency. Yes, but any other altitude in other triangle it will not bisect, only it will be perpendicular. Only median will bisect the base. Isosceles triangle and equilateral triangle have this property that the altitude will divide the base into 2 equal halves. Therefore, BE will be equal to EC. If BC is A, BE and EC is going to be A by 2. right? After recalling all these properties, let us get back to our problem. We need to prove AD square equals to AB square. Here is AD square, right? So let us apply Pythagoras theorem in this triangle ADE. So we know AD square is equals to DE square plus AE square. What is AE? AE is A root 3 by 2 the whole square plus DE measurement we don't know. But how can we write DE? BE minus BD. DE can be written as BE minus BD, right, the whole square, which is equals to A square, root 3 into root 3 is 3. So 3A square by 4, right, plus what is your BE? BE we have found out it as A by 2. So A by 2 minus BD is 1 by 3 times BC, alright. 1 by 3 times BC. BC is the side of an equilateral triangle. We have assumed it as A. So A by 3 the whole square. So which is equals to 3A square by 4 plus take LCM 6. So 3A minus 2A the whole square, which is equals to 3A square by 4 plus A by 6 the whole square. So which is equals to 3A square by 4 plus A square by 6 are 36. Yes. Now take LCM again. 36 is going to be your LCM. 4 9s are. So 9 you have to multiply. 27A square plus A square, which is equals to 28A square by 36. Right. 4 tables. 4 7s are and 4 9s are. So we got AD square equals to, I am doing it here, we got AD square is equal to 7 by 9A square, or 9AD square is equals to 7A square. So that's what we need. We need 7AD square equal to 9AD square, I'm sorry, equals to 7AB square. We got 7A square. A can be replaced with any side, ABO, ACO, BCO, any required side you can replace. So now we can replace A square by AB square. That's what we need to prove. So 9AD square is equals to 7AB square. Hence we proved. Yes. Hope you understood. We have applied all the known property of equilateral triangle and then we have applied again Pythagoras theorem. Yes. Let us see the next question. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitudes. So, with the application or the results of the equilateral triangle, what we have used it for the previous problem, you can try this problem. Of sure you will get the answer easily. So, take the measurement of altitude, assume the side as A. So, altitude measurement will become root 3A by 2 and then apply Pythagoras theorem, dropping altitude there. So, you will get the answer easily. Try this problem. I want you to try. I am not interested in doing all the problems. So, I am giving this as a homework. And the last question, tick the correct answer and justify. So, they have given you all the 3 sides. So, you can try Pythagoras theorem. You can check whether the longest side square is equals to sum of the squares of the other 2 sides. If it satisfies, then it should be a right triangle. Therefore, angle B should be 90 degree. In that way, you can justify it. So, you can do 16th problem as well as homework. So, with this, let us wind up today's class. In the next class, we will do the next exercise. So, do exercise 6.5 question number 12, 16 and 17 as homework. And if you have any doubts, ask me. Thank you, students.